Good morning and welcome to the 8th part of my Kernighan and Ritchie challenge. If you're new to this series, the goal of this video is to read through the Kernighan and Ritchie book, also called the C programming language, 2nd edition from 1988. And yeah, so firstly, I noticed that not too many people have watched any videos beyond the first one, and for YouTube this is perfectly normal. And I'm trying to make these videos as independent from each other as possible. By virtue of making at least each video contain at least some content that can be used outside of the context of this book. And for example, I noticed that some people were interested in the video where I learned getline, and yeah, hopefully there will be more of this later on in the series. And for now, I just have to stay true to my original mission, which was just reading the book out loud, reacting to it, and hopefully providing some good content. And also, yesterday I was probably the first person to actually watch my videos, and I noticed that in one of the videos I made a stupid mistake. Probably because I was tired, and I noticed that in this place I'm checking if so basically this was a program I wrote yesterday on stream in the video. It is a program that reads input from the standard input and reverses each line. And in here, I reallocate the buffer for the reversed line if the length of the line allocated by getLine is greater than the existing buffer size. And I did not store the size of the buffer in this variable, which means that basically on every iteration for every line I would be calling realloc, which is probably doesn't do too much if the buffer is already the desired size, but it's less than optimal. Yep. Okay, yeah, reverse. Let's call reverse with its own source code. Yep. Great. It works just as fast, but I thought, it was stupid. Don't do this at home. And we reached the end of chapter 1, and here we are presented 5 exercises, and as mentioned before, I'm planning to do them all. And yesterday I have already started with the detab exercise. Yes, so basically let me read the exercise for you. Exercise 120, write a program detab that replaces tabs in the input with the proper number of blanks to space to the next tab stop. Assume a fixed set of tab stops, say every n columns. Should n be a variable or a symbolic parameter? Yes, so basically this is something that some text editors may be doing for you. I think in this case it's not happening. Okay, let's say in some Go code, yes, because my clang format my clang format seems to be configured in such a way that it expands tabs to spaces automatically. But for example, in Go code, like yes, so my Go format is configured to actually use tabs for indentation, and this way there is only one character for each level of indentation, and the program is supposed to expand these tabs into spaces. Okay. So in order to like meaningfully test this program, we need some source code to test it on, I guess. And I'll quickly see if I have something in the older, for example, in these older directories, hello world, or this one, or maybe in the second one. Yeah, like this, and this one has a lot of tabs, okay? So I'm going to copy it to 08, and where are we now? Okay, yes, good. So basically, if so if we encounter a tab, we calculate the next tab stop, and we can write some indentation, right? So for I is less than or equal to next tab I plus I, and then put char space. Okay, so this program is detab, and the main loop is iterating over each character in the file, but we are basically operating on lines, and so for each line if we encounter a tab, we calculate the next tab stop. So for example, with a tab size of 4, if we encounter with a tab size of 4, if we encounter a tab, we calculate that the next tab stop will be at the next full basically at the next full multiple of 4. And I haven't tested it yet. I'm going to go ahead and build this file and detab and start going from okay, yeah, that seems to have worked. Let me see if this is the case. So gosh, we need some way to see what actually is in there, right? So right here the int main. So these are new lines, and here in while, what does it say? This is a new line. What's the ASCII tab for? What's the ASCII code for a tab? Yeah, seriously, what's the horizontal tab? It's 09, okay? So we have 09 in here before while, right? Okay, and let's see what, so yes, so our program actually converted this 09, which is a tab, into a yes, so it did convert the tab into into spaces, right? But it also looks like beyond the first time it's actually not doing it correctly. So for example, the first indentation level is correctly 4 characters, but the second one is only 3 for some reason. So let me think about it. So let's say we are at column 5, and maybe we should iterate the column after we print it, right? Something like this, yes. So this works even worse, I guess. Wait, what? So this works for the the second part of the issue, but wait, we are at okay, let's say we start with column 0, right? Now we're going to be starting with column 1. I guess we're going to have to do some debugging. Okay, GTP. So I could try doing this in lldb. Clang-g detab co detab, and then put this in lldb detab, and put a breakpoint on line 15, b main 15, wait, what, b detab clear. Wait, help. Yeah, this is the first time I'm using lldb, I think. No, I want to remove the breakpoint I have just added, right? So current command abbreviation, breakpoint, disassemble, frame, GDB remote, KDP. reproducer, session settings, source, target, thread, trace. And display app help B. File name. Okay, well, that's not too helpful. I'll just do the brain-dead thing and restart it. See line 15. Okay, and run with input from WC. Okay. And it launched, apparently. Okay, does it even work like this? Yes, it does, and apparently it's not so easy read file. Okay, well, lldb executable, settings, set target input path. Okay. Settings, set input path. Okay, breakpoint on detab C15, and we run it. Okay, so now we are at the first time we encounter a tab stop, and let's see what we have. What's our I? Okay, so I is 0, and what's next tab? Next tab is also 0. Step. Okay, what's next tab? Next tab is 4. Step. Next tab is 4 as well. Okay, so we are going to, so it's going to it seems like it's going to iterate up to next tab, right? Okay. And what's and now we are in line. Now we're probably in somewhere. Okay, wait. Now we're probably here on while, right? And what's I? I is 0. Step. What's next tab? Next tab is 4. So it seems like it's going to iterate from that line until the, okay. Okay, I kind of see what is happening. I'm also not entirely sure how to remedy it, but let's see what happens if I just use the less than operator, right? So wait, make file cc equals clang, c flags equals g. Okay, make detab and detab with code from W's. Okay, so I'm not entirely sure why this works, but it works. And I'll just have a sip of my coffee and go to the next exercise. Tell you what, this is amazing coffee. I like when coffee is sour, and this is coffee from Louisa Coffee. This is a chain of Louisa Coffee is a chain of coffee shops in Taiwan, and the beans are from Kenya. I think I'm not entirely sure what the term is, what the term they use for it actually means. We say 肯亚日晒. I think it means they are sun-dried. They are not. I'm not sure if they are even roasted. So anywho. So this exercise works. Will it still work if we change the yes, if we change the tab size parameter to 8, it still works correctly. So this is 4 and this is 4. This is 4 and 4. Okay, so I'll just undo it and keep it at 4, because I think 4 tabs is a nice tab size. Okay, and but that's exercise 120. Exercise 121. Write a program entab that replaces strings of blanks by the minimum number of tabs and blanks to achieve the same spacing. Use the same tab stops as for detab. Whenever a tab or a single blank would suffice to reach a tab stop, which should be the given preference. I think tab should be given preference if we are using it to if we are actually wait. I guess if it's inside the text, I think only in the beginning of a line we should be using tabs, like forcing tabs. Okay, I don't know. Write a program entab that replaces strings of blanks by the minimum number of tabs and blanks to achieve the same spacing. Oh, okay. So okay, this is a bit more tricky, right? Okay, first I'll just start like with all the other exercises. I'll start by iterating over each character, int I c, while c is get char does not equal to end of file, put char c, return 0, I just pass it the source code. Yeah, okay. So this was a very simple concatenation thingy. And now so here I++, so we know that at which column we are, and if c equals a new line, I equals 0, right? Uh, yeah, this is going to be much more difficult, I think. We start I equals 0, blanks equals 0. And now okay, let's say, so for example, let's say we start the line starts with 7 spaces and the tab size is 4, then we have to output 1 tab and 3 spaces. Okay, so if C equals a blank yeah, we only put the character if it's not a blank or a space, right? So if C is a space, blanks plus plus. If C equals is a tab, and if C is tab, blanks, we have to calculate the distance of the next tab stop of it, like we have to calculate the position of the next tab stop. So and right. No, so for example, when we are in somewhere inside the line, well, like in the beginning of a line, and we encounter a space, it means that we want to somehow get to the next space, right? And also in the terminal, I think the tab is going to be 8 characters, or I think yes. So so we want to replace 8 spaces with a tab, and 8 spaces with a tab. Oh. Right. Well, this is, I think this is really difficult. Okay, so if we go over each character, we iterate the position, right? No, we only iterate the position after we printed the character. So, but if we encounter a space or a tab, we need to calculate where we want to get, right? I think it makes more sense, like so like a desired position equals 0. Okay, so if C is a new line, we can say desired position plus plus. If it's a space, we can say we want to get to the next column. And if C is a tab, we can say desired position plus equals tab size, but we want to like round it to the next nearest tab stop. So, well, how did you do it in detab, right? Minus equals desired position. Okay, right? So if desired position is so if we encounter a space, we like so maybe, and then yeah, we want to calculate where we want to get after we encounter the next non-character that is not a space or a tab. And then, so if I for I is, so until I is less than or equal to desired position, while I is less than the desired position, if desired position minus I is greater than or equal to tab size, put char tab, put char tab and I plus equals tab size, continue, and put char space and I++, like this. I have literally no idea if this is going to work. Oh wow. Oh wow. Maybe let's okay, so why is it so? Wow. What's even happening? Are we even? Desired position. Okay, like this. Okay, so now what about if we okay, let me check what happens if we set the tab size to 2 and then run it with the source of detab. Okay, so if we set the tab size to 2 and run it on a file that is indented with spaces, with 2 spaces, then it converts 2 spaces into a tab. And so honestly, this seems to be working. And does it work with the source of entab.c? It does seem to work. So let me write a file to test it, okay? So test empty, okay. So we start with a heading, and then we use 3 spaces. This line is indented at 3 spaces. This line is indented at 2 spaces. 5. This line is indented at 5 spaces. Okay. So now if we run it with the entab test nd, then it converts. Okay, so this was 3 spaces, so it converted it to 1 tab and 1 space. This was indented at 2 spaces, so it converted it to 1 tab. This was 4, 8, 9, and 5 was converted to 2 tabs and 1 space. Great. This is crazy because I really didn't expect this to work. It was I really didn't expect it to work. So basically what it does is we for each line, we in the beginning of each line we start with the column count of 0 and the desired position of Okay, I still haven't tested what happens if there is a tab inside. So, let's say this line has 2 spaces in between the words. Okay, yes. Yep, so it also converted it to a tab. I wanted to shrug it a beautiful way, but I don't think you can see my hands very well. So you can just assume that I shrugged. So anyway, this exercise, for some reason this exercise seems to be done. I just assume it's done. Okay, exercise 122. Write a program to fold long input lines into 2 or more shorter lines after the last non-blank character that occurs before the nth column of input. Nth column of input. Okay, yeah, so basically this program, I think this is a remnant of the old times when people wrote software on punched cards, because punched cards had a line limit of 80 characters, and up to this day you see a lot of people who try to limit their line lengths to 80, which is a remnant of, I think, the 50s or the 60s. And Rob Pike, the creator of Go, he actually made fun of it at some point. Yeah, so basically we want to go to the new line with a hard stop at 80. So let's see if I have any source code that could be used as a test. So for example, in my yeah, this is the source code of my website. So I'm currently writing a blog post, and I do tend to write some pretty long lines. And for example, this line is 186 columns long, so we could just copy like the first 2 paragraphs. And paste it here. And for the fold program, int I c while c equals get char is not equal to end of file, put char c. Okay. And if we set I to 0, and if c is a new line, I equals 0. Okay. Plus plus I. Okay, so we count. We again get the column count, and we define the hard stop at 80. So we can just say if I is 8 is hard stop, put char and I equals 0. Okay. Let's see. Make fold and fold with a test file. Yeah, so this is like a very hard, like a very this is like the this technically works. So we fold at line at column 80, but we can already see that we are cutting the words inside them. So we should probably do something smart, right? So we can do something like we count the time when we started the word, right? So I think we actually may need to store like a memory of the previous words in the line. So okay, well, let's see if we can do something like if last word. Okay, so we store the characters of the last word, right? And we store the index at which the last word started. Okay. So equals 0. Okay. So and we store the length of the current word. Okay, so if the character is a new line, or the character is a tab, or if the character is if it's a space tab or a new line, it means that the word is ending. So and if word length is greater than 0 and I plus word length is greater than hard stop, we break the line. Okay, so put char I equals 0, word length equals 0, word 0 equals 0. No. If the word length is I'm not sure, I think I'll write something like this, void empty buffer yeah, this is my professional upstairs neighbor, empty buffer and yeah, for I int I equals 0, I is less than length, I plus plus, buffer of I equals 0. So I wrote a function too, so that we can easily empty the buffer. Like this. So that's just to make sure we don't have any trash remaining, right? And if we don't have to put a null terminator after the word. So if we encounter a space or a tab or a new line, it means we are at the boundary of a word. So if the length of the existing word is greater than 0, and if the current column plus word length is greater than hard stop, when we just we break the line and we put everything we had in the buffer and I equals word length and word length equals 0. Okay, right. Otherwise, and continue. Yes. And if we are forced to break the line because the last word stored in cache is would overflow the line. Okay. If so if it's not greater than, we can put the next word, right? So printf and then we put char. Okay, let's see. So if we are yeah, this is probably not ideal. Oh wow, this is I can't even begin. Well, yes, okay, so we get some trash, and I've obviously this is much more complicated than I would have thought, and I will have to think a bit more about it. And for now, I'll probably just wrap up this video, and yes, so if you have enjoyed watching me struggle, and if you think I'm an idiot for writing this program so poorly, please let me know in the comments. And yeah, it's probably simpler when I'm making it, but I just need to figure it out. And in the meantime, I hope you learned something from my endeavors, and you can tune in to the channel tomorrow tomorrow we'll hopefully finish 122, and wow, write a program to check. Yeah, so 124, like, dude, when you open a programming course these days, it's like learn Python in 3 hours, and then you do a course and you can write a hello world program, right? And this is chapter 1 of this book, teaching C programming to beginners, and the last exercise in the chapter is write a syntax checker. Like, seriously, this is so difficult for a beginner, and they just throw it at you and say, yeah, maybe you can do it. Yep. I mean, I love this book for the difficulty of the exercises, and for the overall approach of, yeah, you can figure it out, you have to figure it out, there is no internet, the best you can get is Usenet, right? Crazy. Anyway, thank you for watching. I hope you learned something and don't try this at home.